The billion-dollar licensing hedge. Apple is reportedly paying Google $1 billion annually to license Gemini models for Siri, but the actual technical pivot isn't in the cloud. While the marketing focuses on conversational fluidity, the internal architecture has shifted toward a local context engine that prioritizes deterministic data over probabilistic guesses. This move effectively splits the assistant into two brains: a massive, licensed LLM for general world knowledge, and a local personal knowledge graph for your private data. By siloed off the personal context, Apple avoids the massive compute and privacy costs of feeding private user tokens into a third-party server. This is less about making a better chatbot and more about building a retrieval layer that actually knows your specific life without a round trip to a data center. The mechanics of this local retrieval are where the real engineering happens. Deterministic graphs versus probabilistic rage. Most AI systems use standard retrieval augmented generation, or RAG, which relies on vector embeddings to find similar text snippets. The new context engine replaces this with semantic indexing, a technique that builds a structured knowledge graph directly on the device's NAND storage. Think of it like the difference between a library search bar and a detailed map of every book's relationship. When you ask about a meeting with your boss, a standard LLM calculates the most likely word following your query, but Apple's engine performs a deterministic lookup in the graph. It identifies the entity boss, links it to a specific contact ID, and pulls the relevant calendar event. This eliminates the hallucination risk inherent in pure vector search. However, the limitation is scale. Maintaining a live graph across terabytes of local messages and emails creates a massive indexing overhead that taxes the neural engine's background cycles. App intents as the agent interface. The interface between the model and your data isn't a simple text prompt, it's a system of app intents. Apple has spent 2 years forcing developers to define every app function as a structured piece of metadata that a system orchestrator can read. This orchestration layer acts as a traffic controller, deciding whether a request needs a local on-device model for a simple task or needs to escalate to private cloud compute for complex reasoning. If you ask to send a file to a specific person, the orchestrator doesn't just guess which app to use, it consults the app intent manifest to see which installed applications are authorized to handle that specific file type and recipient. It's a rigid, programmatic approach that lacks the flexibility of an unconstrained agent, but it provides the reliability needed for a system-level operating tool. This structure is what enables the new on-screen awareness features. The real implication. The transition to a personal knowledge graph signifies that the operating system is no longer being built for human users, but for autonomous agents. By formalizing every interaction through app intents and indexing every private data point into a semantic index, Apple is effectively creating a machine-readable map of your digital life. This reduces the friction for an AI to act on your behalf, moving Siri from a voice-to-text interface to a true system broker. For developers, the message is clear. If your app doesn't have a robust intent schema, it will be invisible to the OS intelligence layer. The skepticism here should focus on the heavy licensing of Google's Gemini. It suggests Apple's own foundation models still can't compete on global reasoning, even if their local retrieval is superior. Watch for the first major performance benchmarks comparing this hybrid graph retrieval method against the pure long context windows of competitors this fall. Subscribe for more